Okay, section 5.5 talks about evaluating quadratic equations. And if you look at example 1, A should not be hard. F of -4, you just pop that -4. So what we have is, 3x squared plus 2x minus 11 is the same as f of x. They want to know f of -4. Of course, we just take this -4 and pop it in for every one of these x values. That shouldn't be difficult for you. But B, when it says x, they want you to find x if f of x is -6. Well, what do we do with this? We have to put the -6 in for this f of x. And then we go ahead, write the rest of the equation. Now, when you get stuck in math, the solution generally is to set the equation equal to 0 and solve for x. So I'm going to go ahead and set this equal to 0. I'm going to add 6 to both sides. So I get 0 equals 3x squared plus 2x minus 5. Because if I add 6 to both sides, I get a -5. So now, what I want to do is, this is a quadratic equation. I want to figure out where this is true. I can use the quadratic equation on this. So I use the quadratic equation on this to figure out what my x values are when the y value is -6. Now remember, this is a parabola. And parabolas will look something like, I don't even know, I'm just saying, here we go. So a lot of times you're going to get, if you're looking at y value of, in this case, they want a y value of -6. 1, 2, 3, 4, 5, 6. So let's just imagine this was it. Well, it might look like this, right? So I'm looking for 2 points here. The quadratic is going to give me those 2 points. And I would just fill it in, the opposite of b, -2, plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2a. You need to be able to solve that down. All right, and you shouldn't need a calculator for this, I'm thinking. But if you do, you really need to stop using the calculator so you can start thinking. This should be straightforward. You're using the quadratic to solve. Now, question C of example 1 is, they want you to find the x-intercepts. Well, how do we find x-intercepts? X-intercepts are where y equals 0, right? So we start off with this equation, y equals 3x squared plus 2x minus 11. If we want the x-intercepts, the x-intercept is where y equals 0. So we got to put a 0 in for y. 0 equals 3x squared plus 2x minus 11. Now we have to solve. When we solve, we'll get our x-intercepts. Well, rather than trying to factor this, which is impossible, I am going to use the quadratic equation. So I get the opposite of b plus or minus the square root of b squared, which just makes me think that I did this wrong on the last step because I don't think I had the negative in front. So make sure you're following the quadratic equation right. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. You solve that and you'll get it. Now again, remember on section B of this problem, I may have forgotten that minus sign, I'm not sure. So that will give you your x-intercepts, and so they would of course look like some x value 0, some other x value 0. All right. So just write them down as points, or in this situation they just say x equals 1 and x equals 1.6103 and x equals -2.27669, whatever. I prefer them. I prefer your answers not to actually go down to the 1.61. They have two things. They have -2 plus or minus the square root of 136 over 6. This is how I prefer your answers. I definitely do not prefer your answers like this, 1.6103. I will take this all day long. It's better. All right? One thing that you would want to do here, though, before you finish this answer is I would like to try and reduce this a little bit. And I know that I can get can I get a 4 out of that? Yes, I can. So if I want to get a 4 out of that, 136 divided by 4 would be 34. So I would get minus 2 plus or minus 2 square root of 34 over 6. That way I can factor out this 2. So I get 2, negative 1 plus or minus the square root of 34 over 6. And then I can cancel this down to where that's a 3. It's cleaner, it's better. I will accept this. This is more mathematically sound. You want to reduce this stuff. If you're having trouble with how to reduce, you need to speak up and let me know, because this is what's going to happen. You're going to sit there and say, oh, I got it, I got it, I got it. Then you're going to give out a test, and I'm going to mark your problems completely wrong, and you're going to wonder what just happened. So if you do not understand what's going on here, and you don't speak up, it's your own fault for failing. Just telling you now. I just broke the news to John that you can't get higher than a 75 on a retake. Now, if you do a really good job on a retake, I'll consider giving you a whole new test, non-open book, where you could get a better grade. But you guys are going to have to step it up. All right. Example 2 says if f of x equals 3x squared plus 2x minus 11, they want to know if f of x, they want to know, can it equal, I'm going to put a question mark over it, like, can it equal negative 5? Or can it equal, and that's not a mathematical symbol, I'm just making that up. Can it equal negative 15? Is that possible? And so how do we do this? Well, we go ahead and we say, okay, let's just make f of x negative 5. So I put a negative 5 there, and I get 3x squared plus 2x minus 11. So now what do I have? I have a quadratic. What do I do with it? Well, when you don't know what to do with something, set it equal to 0 and solve for x. How do you solve for x? You factor and solve, or use the quadratic equation. So I'm going to set it equal to 0. I'm going to add 5 to both sides. So I get 0 equals 3x squared plus 2x minus 6. Now I use the quadratic on it. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now notice, a lot of kids are going to forget to pick up this, that this negative sign here is actually part of that value, and don't forget to put that in. You got to remember to put that in. Now, when you do all this, boom, okay, you're going to get negative 2 plus or minus the square root of, this would be 4, and this is, of course, becomes a positive because I've got 24 times 3, which is 72, so I get 76 squared root of 76 over 6, because 2 times a is 6. I'm thinking that's what it is. Let's see. So this is how I would try and solve it, right? Well, as long as this is a positive number, I'll get answers out. So if that's a positive number, I'll get an answer. I know that negative 5 would work. I don't actually have to go through this whole mess. I could just do, if I have opposite b plus or minus the square root of b squared minus 4ac all over 2a. What tells me whether or not this has an answer, actually can make it happen, is this part. I don't have to do anything else. If I just do b squared minus 4ac and it turns out to be a positive number, then I'm golden. It's true. It really does happen. That's really an answer. So if we get a 0 or a positive number, then that can exist. If we get a negative number, it can't exist. So in the next example, you have f of x, can it equal negative 15? Well, put negative 15 into this equation. So let me just do that real fast. Negative 15 equals 3x squared plus 2x minus 11. So I get 0 equals 3x squared plus 2x plus 4. I will use this. So my b here is 2. My c here is 4. So I get b squared minus 4ac, which would be 4 minus 4 times a, which is 3, times c, which is 4. 4 minus, what, 48? That's definitely a negative number. You can't actually find an x value that makes a y value of negative 15. It does not exist because the discriminant is negative. And if the discriminant is negative, you only get imaginary numbers. If you only have imaginary numbers, you don't have real solutions. Good luck.